Okay, in this problem there is a sailboat race, and it consists of 4 legs, and the finish line of the course coincides with the starting line. So basically what that looks like is you kind of go out this way with leg A, and then you come this way with leg B, and then this way with leg C. So there's like A, this is B, and this is C. And then you turn and you come back to the starting point, and that is leg D. We actually know A, B, and C. We do not know D. We actually would know the resultant. If you add A plus B plus C plus D, it ends where it starts. So the resultant is actually 0. So we want to add up A, B, C, and then unknown D to give us a resultant of 0. All 3 of the legs the magnitudes are given and the directions are given, and the directions are all given from north. So this is really nice. We don't even really need to actually make a drawing of all the vectors because all the angles are given from north. We can actually just start writing out the vectors in component form. So vector A would be, I hat would be 3.20 times the sine of 50, that'd be I hat, and then plus 3.20 cosine of 50, and that would be our j hat. Vector B would be likewise. So we have this nice pattern, I hats are sine and j hats are cosines, as long as the angle is from north, if you remember that. So the next one, B, would be 5.10 sine of 305 I hat plus 5.10 cosine of 305 j hat. And vector C would equal 4.80 sine of 247 I hat plus 4.80 cosine of 247 j hat. And then D is what we're actually trying to find. We don't know what D is, but we do know that they all add up. They all add up to give us the resultant vector. And the resultant vector we know is 0 I hat plus 0 j hat. The resultant vector is 0 since we ended where we started. So I could rewrite all of these. I could do the math on these and maybe rewrite them. So vector A is a plus 2.45 I hat and a plus 2.06 j hat. Vector B is a minus minus 4.18 I hat and a plus 2.93 j hat, and vector C equals a negative 4.42 I hat and a negative 1.88 j hat. And then vector D is what we're trying to find. And then, of course, resultant, again, is 0 I hat plus 0 j hat. So if you look at the numbers here, let's look up here at vector A. If we have vector A up here, you'll see it should have a positive x and a positive I hat and a positive j hat, which it does. Vector B right here is going up this way. It should have a negative I hat and a positive j hat. It does. Vector C is coming down this way, so it should have a negative j hat and a negative I hat. It does. So what should D? Vector D should have a negative j hat and a positive I hat. So all we need to do is take, to find this I hat right here for D, you would take this resultant. So if you have A plus B plus C plus D equals R, then to find D, you take R minus A minus B and minus C. That's what you would do. So I could take 0 minus a 2.45 minus a minus 4.18, so add 4.18, and then minus a minus 4.42, so add a 4.42, and you would get your answer. Another way to do that is to go ahead and add up all three of these things, add up A, B, and C, and then D, what would you add to that to get D to result in to be 0? You would just add these all up and then just use the same number but the opposite sign. So that's what we could do. Same thing with all the J hats. So if I add all of these A, B, and C up, these negative, I'd have a 2.45 I hat minus 4.18 I hat minus a 4.42 I hat. I'm going to get a negative 6.65, which means this needs to be a plus 6.15 I hat. The J hats, if I added those all up, I would get a plus. So a 2.06 plus 2.93 minus a 1.88 gives me a plus 3.11. So I'm going to need a negative, I'm the opposite sign, 3.11 J hat. So now if you added up this and this and this and this, it should equal 0. And this, and this should equal 0 also. So now there is our component vector for D. So what is that in regular form now? So I'm going to draw a grid. I'm going to go, let's change the color here. I'm going to go over 6.15, and I'm going to go down 3.11, and there's the vector D, which of course looks like that. Okay, and to get the magnitude, I'm going to do Pythagorean's theorem on those two sides. And if you do that, you end up getting 6.9 kilometers. And then to get this angle right here, I would do tangent of that angle equals 3.11. Don't worry about the negative. Over 6.15 inverse tangent. I get this angle here. And then I would take that angle. Let's see, that angle I think ended up being like 27, I think. 27. But what we want to do is we want to measure it from north. Okay, we want to measure it from north. So it'd be 90 plus the 27 was at 117 degrees. Okay, so that's how we can find leg D when we actually know the resultant and we know the other three components.